welcome to our channel Euclid Mathematics. We have started lecture series on MHT CET Mathematics, JEE Mains, JEE Advanced and other competitive exam too. So here in my today's example, I will explain one of the question which is from MHT CET previous year question paper, which is completely based on our integration. So we have to apply the integration and we have to use the limit of our integration to our example. Okay, so now let's get start our question. First of all, we read the question and then we will move further for solution. So let's read the question. Here in our question number 31, we have given integral under a function x sec square x dx. Okay, and integration is having limit 0 to pi by 4. So we have to find out the integration first and then apply the limit of 0 to pi by 4. See, it is quite easy question. Just we have to apply the integration and then substitution of a limit. It is quite easy. Okay, and options are given: a pi by 4 plus log root 2, b pi by 4 minus log root 2, c 1 plus log root 2, d 1 minus 1 by 2 log 2. Okay, so we have to figure it out which one of the option is correct. Okay, so now let's get started our today's solution. We will figure it out how the solution it is. Okay, here in our question we have integral 0 to pi by 4 x sec square x dx. Okay, it seems like that we have two different function here, first algebraic function and trigonometric function in the form of a product. Okay, so whenever we have such a product form in integration, we always use by-part rule for integration. Okay, so let's apply the by-part rule, then we'll see how can we get the solution. Okay, so a by-part rule means we use integration of u into v. Okay, integration of u into v. So by-part rule for integration, it says that if we have integration of u into v, we can write it as the u into integration of v minus integration of a derivative of u into integration of v dx. Okay, so this is only we have to find it out. Okay, but when we are selecting u and v, so this question is quite easy. Just we can select u and v very easily. But when we have exponential, logarithmic, inverse trigonometric function, okay, so that time how we can select first function and second function. Okay, so here we can see the first function and second function we have to apply here as a ILATE rule. Okay, ILATE rule we have to apply here, and which can be elaborated as I means inverse trigonometric function, second L means logarithmic function, third A means algebraic function, fourth T means trigonometric function, and fifth E means exponential function. So we have to select first function and second function in this order. Okay, so here I select first function and second function. So first function it will be preferable as u as which is equal to x. Why u which is equal to x here? Because we by using Euler rule we always prefer algebraic function before trigonometric function. Okay, we always prefer algebraic function before trigonometric function. So we can see that x is algebraic and sec is a trigonometric. So we have to consider u as a algebraic x here and sec is a trigonometric v as a second function. Okay, so I got the first function u x, second function v sec square. Okay, now apply by part rule of integration. It says that integration of u into v, which is equal to u into integration of v minus integration of a derivative of u into integration of v with respect to given x. Okay, like a dx is there. But whenever we have substitution of a limit, always make sure that we have to find out first of all integration, then differentiate it, take it together, and then apply integration here. Okay, so don't apply limit of integration here. Okay, so we have to apply limit of integration to whole our second bracket. Now let's get start our solution. I will explain to you all in detail. Okay, how we can apply. Okay, now here we can see I consider u as a x, u which is equal to x, v as a sec square x. Okay, that means u into integration of v minus integration of derivative of u, derivative of x, okay, into integration of v. So u in v is here, ux v sec square x. I substituted all these values here in this result only. Okay, now here x as it is, sec square x, and other values here, then x into integration of a sec square x. So here x as it is here, integration of a sec square is a tan x. Okay, or differentiation of a tan x is a sec square x. It is a tan x here. Apply limit pi by 4 to 0. Okay, pi by 4 to 0 here. So we have to substitute one time pi by 4 minus and one time 0 minus integration of a d by dx of x, which is a 1. Okay, so 1 multiplied by remaining term itself, that term here, and integration of sec square x dx. Okay, so integration of sec square x is a tan x, and we have integration of 0 to pi by 4 here. Okay, dx. Now find out further integration for this tan x. Okay, So it can be written here as x tan x. Okay, so put x tan x here like this, and then apply the limit. Okay, so pi by 4 tan pi by 4. Okay, pi by 4 tan pi by 4 multiplied by 0 tan 0. Okay, 0 multiplied by tan 0 is which goes to 0. Okay, tan 0 is a 0. Tan 0 is a 0 multiplied by x is a 0. 0 multiplied by 0, it goes to 0. That means the term of a negative 0, it goes away from here. Only remaining term pi by 4. So pi by 4 tan pi by 4 minus again integration of a tan x. Tan x having integration log of sec x. Okay, which is the integration log of sec x. Apply pi by 4 to 0 limit. Okay, now next step we will get it here. So pi by 4 as it is, tan pi by 4. Tan pi by 4 having value 1. Okay, tan pi by 4 is having 1 minus log of sec x. So log of sec x, we have to substitute pi by 4 and 0. That means log of sec of pi by 4 minus log of sec of 0. Okay, x one time pi by 4 and another time 0 is there, and there's subtraction here. Okay, so pi by 4 as it is, log of pi by 4, sec pi by 4, that means sec 45. Sec 45 which gives root 2 value minus sec 0. Sec 0 is a 0 and sec 0 is 1. Sec 0 is 1 and log of 1 we get the value 0. Okay, so I got the step here, pi by 4 minus log root 2 minus log 1. Okay, so log 1 is having value 0, so it doesn't affect our solution. Okay, so leftover value is a pi by 4 minus log root 2, and which is given in our option number B. Okay, so our correct option is a pi by 4 minus log root 2. It is quite easy question from MHT CET previous year question paper. Okay, I hope so you all have understood this exam solution. It is completely based on integration and by part rule of integration. Okay, so we have to apply only the some integration formulas here. Nothing is difficult here. Such a type of the question, it gives us easy mark. So we have to solve this question always first in our exam. Okay, so I hope so you all have understood my today's lecture. So thank you everyone. Thank you for my lecture.